Hi guys, today I'm going to discuss about random forest. So, random forest is an ensemble classifier that consists of many decision trees and outputs the class that is the mode of the classes output by individual trees. The term came from random decision forest that was first proposed by Tin Cam Ho of Bell Labs in 1995. The method combines Breimann's bagging idea and the random selection of features. Decision trees are individual learners that are combined. They are one of the most popular learning methods commonly used for data exploration. One type of decision tree is called CART, classification and regression tree. CART, greedy top-down binary recursive partitioning that divides feature space into set of disjoint rectangular regions. Regions should be pure WRT response variable simple model is fit in each region. Majority vote for classification, constant value for regression. Here is a simple dataset with two predictors and one greedy recursive partitioning along TI and PE. Algorithm. Each tree is constructed using the following algorithm. Number 1. Let the number of training cases be n and the number of variables in the classifier be m. Number 2. We are told the number m of input variables to be used to determine the decision at a node of the tree. M should be much less than m. Number 3. Choose a training set for this tree by choosing n times with replacement from all n available training cases. Example, take a bootstrap sample. Use the rest of the cases to estimate the error of tree by predicting their classes. For each node of the tree, randomly choose m variables on which to base the decision at that node. Calculate the best split based on these m variables in the training set. And number 5, each tree is fully grown and not pruned, as may be done in constructing a normal tree classifier. For prediction, a new sample is pushed down the tree. It is assigned the label of the training sample in the terminal node it ends up in. The procedure is iterated over all trees in the ensemble, and the average vote of all trees is reported as random forest prediction. Here is a sample flowchart of algorithm. So first, for each tree, you will need to choose training data subset. Is the condition hold each node? If yes, it will calculate prediction. If no, build the next split. Under build the next split, you can choose variable subset, then go to, or if not, for each chosen variable, you can select sample data, sort by the variable, or compute Gini index at each split point. To choose the best split. And after that, you will go to end. Random forest practical consideration. Splits are chosen according to purity measure. Example, squad error, regression, Gini index or Devinance classification. How to select n. Build trees until the error no longer decreases. How to select m. Try to recommend defaults half of them and twice of them and pick the best. Features and advantages. The advantages of random forest are: it is one of the most accurate learning algorithms available. For many datasets, it produces a highly accurate classifier. It runs efficiently on large databases. It can handle thousands of input variables without variable deletion. It gives estimates of what variables are important in the classification. It generates the internal unbiased estimate of the generalization error as the forest building progresses. It has an effective method for estimating missing data and maintains accuracy when a large proportion of data are missing. It has methods for balancing error in class population unbalanced datasets. Generated forests can be saved for future or use on other data. Prototypes are computed that give information about the relation between the variables and the classification. It computes proximities between pairs of cases that can be used in clustering, locating outliers, or by scaling, give interesting views of the data. The capabilities of the above can be extended to unlabeled data, leading to unsupervised clustering data views and outlier detection. It offers an experimental method for detecting variables interaction. For the disadvantages, random forests have been observed to overfit for some datasets with noisy classification or regression tasks. For data including categorical variables with different numbers of levels, random forests are biased in favor of those attributes with more levels. Therefore, the variable importance scores from random forests are not reliable for this type of data. RM additional information. Estimating the test error. While growing forests, estimate test error from training samples. For each tree grown, 33 to 36% of samples are not selected in Bootstrap, called out of Bootstrap or OOB samples. Using OOB samples as input to corresponding tree, predictions are made as if they were novel test samples. Through bookkeeping, majority vote, classification, average regression is computed for all OOB samples from all trees. Such estimated test error is very accurate in practice, with reasonable N. Estimating the importance of each predictor. Denote by E upper the OOB estimate of the loss when using original training set D. For each predictor, XP where P, E, I to K, randomly permute PTH predictor to generate a new set of sample D. Compute OOB estimate E upper K of prediction error with the new samples. A measure of importance of predictor XP is E upper K minus E upper, the increase in error due to random perturbation of PTH predictor. For my conclusion and summary, it is very fast. RF is fast to build, even faster to predict. Practically speaking, not requiring cross-validation alone for model selection significantly speed training by 10 times to 100 times or more. Fully parallelizable to go even faster. Automatic predictor selection from large number of candidates. Resistance to overtraining. Ability to handle data without pre-processing. Data does not need to be rescaled, transformed, or modified. Resistant to outliers. Automatic handling of missing values. And for the last, cluster identification can be used to generate tree-based cluster through sample proximity. So that will be all about random forest. Thank you, and I hope you learned something.